I'm here to talk to you about video object tracking in computer vision. What are the techniques involved and its application? Object tracking is a fundamental job in computer vision that includes detecting and tracking items of interest in a video stream. It has a wide range of applications in fields such as surveillance, robotics, and autonomous vehicles. Object tracking aims to accurately identify and track an object across time with changes in appearance, scale, and orientation. Template matching is a simple and straightforward object identification technique that includes comparing a template image to a bigger search image to find the object of interest. It operates by moving the template picture over the search image and calculating a similar score at each area. The place with the highest similarity score is assumed to be the object's location. Identifying distinguishing elements in an image, such as corners or edges, and using them to identify objects is what feature based detection is all about. This method frequently used in conjunction with a descriptor which offers a numerical representation of the feature. The scale invariant feature transform is the most often used descriptor because it is resistant to changes in scale, rotation, and illumination. In computer vision, motion estimation is a critical component of video object tracking. It involves analyzing a video's consecutive frames to determine the motion of objects in the scene. This data can be used to track objects in real time, predict their future positions, and detect anomalies or events in video. Here are some common motion estimation techniques. Optical flow calculates pixel motion between frames using brightness and gradient information. To estimate motion, block matching divides the image into blocks and compares them between frames. Phase correlation uses Fourier transformation to estimate motion based on frequency domain phase shifts. Challenges in motion estimation. In situation with occlusion, motion blur or complex backgrounds, estimating motion can be difficult. Furthermore, different techniques may be more appropriate for different types of motion or video content, and selecting the right approach may necessitate extensive experimentation and tuning. Now let's see the applications of object tracking. Surveillance and security. It can be used to monitor and track people, vehicles, and objects in real time for security purposes. Automotive industry. Object tracking can be used in autonomous vehicles to detect and track other vehicles, pedestrians, and obstacles on the road. Medical imaging. Object tracking can be used to track organs, tumors, and other structures in medical images for diagnosis and treatment planning. Sports analysis. Object tracking can be used to track athletes and balls during games for performance analysis and training.